Hi everyone, this is the video lesson for Pascal's triangle and binomial theorem, day 1, part 2. So before we continue, if you haven't watched the first part of this video, please go back and watch this. You can even warm up again by writing down the first 5 rows of Pascal's triangle. Let's continue. So at the end of part 1, we talked about Pascal's identity, something that you would do if you take data management, and I haven't written down the formula yet. So I'm going to go back, show you what the formula looks like, and we'll give a little bit more in terms of combinations. So if you look at the triangle and you want to relate this in terms of combinations, which you can express as and choose R, Pascal's identity equals to or is and choose R, which equals to n minus 1 choose R minus 1 plus n minus 1 choose R. So again, in case looking at this and you're thinking, I'm lost, I don't get it, how is this related to Pascal's triangle? And let's kind of give you a small connection there. Let's not go too deep into the course in terms of data management, but here's another way of looking at it. So first of all, when we say and choose R, this is really, by definition, combinations, something you're going to do for sure if you take data management, and it's going to be chapter 5. And of course, chapter 4 is permutation, and combination is where order doesn't matter. Order does not matter. So let's just give you an intro. Let's not give you the whole unit in this one video, but the way you look at it is you can say, okay, I see Pascal's triangle, 1, 1, 1. In the world of combinations, that's going to be 0, choose 0. 1, choose 0. 1, choose 1. Likewise, if I kept going, it could be 2, choose 0. 2, choose 1. 2, choose 2. Then we do one more, and then let's make the parallel. So you could say 3, choose 0. 3, choose 1. 3, choose 2. And 3, choose 3. So I hope you can see this. What I'm trying to tell you is that 1 is the same as nothing, choose nothing. And we'll talk about that in a moment. 1, 1 is 1, choose 0, 1, choose 1. And likewise, if I had to keep going, 1, 2, 1 is basically 2, choose 0, 2, choose 1, 2, choose 2. And of course, last but not least, if you look at 1, 3, 3, 1, that's 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3. So let me just kind of explain this a little bit before we officially start binomial theorem. The reasoning is like this. 0, choose 0. That means there's nothing in front of you. And we're asking you, how many ways can you choose nothing if there's nothing? Well, the answer is 1. There's one way. Or I could say there's one item in front of you, and I'm asking you to choose nothing. Well, there's one way. Or I can say there's one item in front of you, and you must choose one item. Well, you would pick up that item, which means there's one way. I'm going to try a couple more, and then we'll kind of end it there without deep diving into combinations. But 2, choose 0 just means you have 2 items in front of you, and you're choosing nothing. There's one way. 2 items in front of you, you're choosing 1. Well, you can choose the first item or the second item, which means there are 2 ways. 2, choose 2, your 2 items in front of you, you must pick up both of them at the same time. And again, order doesn't matter. So 2, choose 2 is going to be 1. I hope you get the idea. 3, choose nothing. There's one way. 3, choose 1. Well, you can choose the first one, the second one, or the third one. So there'll be 3 ways. 3, choose 2 is where you have 3 items. If you call them A, B, and C, right? And maybe I'll write this out so you can really see what I'm talking about. And if you like this, data management could be the course. And if it isn't, it's okay too. So you can say, okay, I'm choosing 2 of these. I'm choosing A and B, or A and C. Or you're thinking, nope, I'm choosing B and C. So there's 1, 2, and 3 different ways. Last but not least, 3, choose 3 means there are 3 items. You got to pick up all 3 of them. Order doesn't matter. There's one way. So that's the first relationship you should be able to connect between Pascal's triangle and combinations. So if you go back now to Pascal's identity, this is just simply saying that to find the next number, you've got to take the sum of the previous 2. And I kind of mentioned this at the end of the first video. In this case, right, this is really just 1. And this becomes the other 1. And when you add them up, that's going to become 2. So let's go back and finish the rest of this list by reactivating all the skills that we've mentioned from the first part. Can you predict the next row of numbers? The answer is yes, and we can use this formula or this equation. Number 2, add the numbers in each row. Is there a pattern in the sums of these numbers? And the answer, again, is yes, right? And of course, it depends if it's the even or the odd row, but there's basically symmetry on the left and right. Do any numbers repeat? Again, the answer is yes, right? The numbers on the left will reoccur again on the right, except the middle number will occur once depending on the row. Can you find a pattern in the diagonals? Can you find a pattern in the diagonal numbers? And of course, the answer is yes. And this is something that you can even look at in this diagonal. You just add 1, right? 1 plus 1 is 2, 2 plus 1 is 3, and it just keeps on going. The next one, 1, 3, 6, 10, 15, you're first adding 2, then you're adding 3, then you're adding 4, then you're adding 5. And if you keep going, you can find other patterns. This is very important, especially in this unit when we go through sequence and series, and you're going to kind of figure all this out. Now, let's keep going. The name of this video is Pascal's triangle and binomial theorem. So we have to introduce this and relate them. And we're spending 4 videos or 2 days, 2 parts per day to explain this. So binomial, of course, just means you have 2 terms. So binomial theorem just means there's a theorem that can help you expand any binomial to some power. So again, you can read all this, but I really want to give you the most important connection. Now, this you know how to do. I mean, anything to the power of 0, that's going to be 1. I think you know that. Anything to the power of 1 remains unchanged. A perfect square, for sure you did this back in grade 9, grade 10. A perfect cube, maybe you did this in grade 12, advanced functions, maybe in grade 11 medallion, maybe in grade 10 medallion, in the grade 10 university, it depends. But you can expand this because it's x plus y multiplied by itself 3 times. So you can verify these on your own. But the question becomes, instead of expanding this multiple times, is there a faster technique? And the answer is, of course. And the way you can do this is by referring to Pascal's triangle. So I'm going to connect this with you on the next page. I just want to make sure you can see this first of all. If you look at these numbers, 1 and 1, it's right there, 1 and 1. If you look at these numbers, 1, 2, and 1, 1, 2, and 1. So I hope you see a pattern, 1, 3, 3, 1, 1, 3, 3, 1. And if you look at the exponent, this is exactly the row number that we were referring to. So the reason why we didn't call them row 1, we started with row 0, then row 1, then row 2, is because everything is related, right? Everything's connected. So the exponent is the row number that you refer to. So if the exponent is 2, you refer to row 2. And if the exponent is 3, you refer to row 3, and so on. So I'm going to demonstrate how to do this using Pascal's triangle. And technically, of course, you can use binomial theorem. That works perfectly as well. So there's the pattern that you can correlate. But let's actually show you how to do some of this. Here we go. Make sure you try this with me. Example number 1, expand. Now, if you have x minus y in brackets to the power of 6, here's the first step. Since the exponent is 6, you're thinking specifically row 6. And you can tell by now there are 7 terms in row 6. So you copy x and y. And you copy this exactly 7 times. So again, whatever the exponent is, you copy that plus 1 more. So if the exponent is 6, you copy it 7 times. If the exponent was 100, you would write this 101 times. So I'm going to write this 7 times. And I'm running out of space, so I'm going to do it here. Just like that. Now, the second step is, now let me count this. I think I did too many. There we go. The second step is to look at the exponent and you count down. So you start with 6 and you count down to 5, 4, 3, 2, 1. And if you're doing it right, you always end with 0. Then you go backwards, same pattern, 6, 5, 4, 3, 2, 1. And if you're doing it right, you always stop at 0. Now the next step is you look at the row number. And as I said, the exponent is going to be 6, which means you look at row number 6. And you write down all those numbers. And you're going to write down 1, 6, 15, 20, 15, 6, and 1. Now last but not least, you have to look at the sign. If it's a plus sign, you put a plus in the entire expression. But if it's a minus sign, the signs alternate. You start with the plus at the beginning, then minus, then plus, then minus, plus, minus, plus, just like that. So here comes the final step. If you clean this up a little bit, this equals to x to the power of 6 minus 6x to the 5 times y plus 15 x to the 4 y squared minus 20x cubed y cubed plus 15x squared y to the 4 minus 6xy to the 5 plus y to the 6. Hopefully you can write better than me. You can write them in one line instead of two parts. Now, I'm going to show you one more, then you try the other one. So if you look at B and C, I'm just going to make the assumption that C looks more difficult than B. So you try B, I'm going to show you C, and then we'll continue in the next part. We're going to show you so much more. So again, same idea. If the exponent is going to be 4, I'm going to copy this exactly 5 times. And here's the first one, second one, third one, and the last case, the fourth one. Again, the second step is to look at the exponent. If it's going to be 4, you have to count down. So I have to copy this 5 times. Let's do one more right there. So if you count down, it's going to be 4, 3, 2, 1, and 0. You go backwards, 4, 3, 2, 1, and 0. Again, the exponent is 4. So you look at row number 4, which means it's going to be right here. And the numbers are 1, 4, 6, 4, and 1. Because it's a minus sign, the signs alternate, plus and minus, and plus. Now, here comes the final answer. Again, let's make sure your mechanical steps are strong. You can always take a calculator. You can even try this first before pressing play. 3 to the power of 4 is going to be 81. X to the 4 is going to be x to the 4. Next, there's 3 to the power of 3. That's going to be 27. You multiply this by 4. That's going to be minus 108. X to the power of 3 divided by y squared. I hope you're still with me. 3 times 3 is going to be 9. 9 times 6, that's going to be 54. So plus 54 x squared divided by y to the 4. Minus, again, you have 4 times 3, that's going to be 12 times x divided by y to the power of 6 plus 1 over y to the power of 8. So keep going. Try numbers 2 and 3, and we'll continue in the next part. I hope this makes sense.